What's up, guys? It's Simon Fiaz, and more multiple choice questions on. I think it's titrations after back titrations, multiple choice questions. Um, yeah. Before I carry on with this video or even start it, I just like to say chemistry now is going to be on my main YouTube channel. So all of the content now on my main YouTube channel will be chemistry or maths, but I'm thinking, yeah, just all chemistry. So I've got YouTube for chemistry and psychology. I will be posting on Instagram very, very soon, maybe tomorrow. I keep saying tomorrow I'll do it. So I do need to do it. And then it's just like racking up those psychology videos, maybe hundreds, a couple of thousand. And it's just going to be through like key definitions, terms, descriptions, of methods, research methods, all of that. Yeah, that'll be my Instagram, and I'll probably put a link in my YouTube bio. But yeah, and for my YouTube channel, more multiple choice questions. Once I've done with that, then I'm going to probably be doing like a couple of past papers a week, and we'll see. Question 5. What is the volume of this required to neutralize exactly this? So, I could find out. Wait, well, 0.100 divided by 0.200. 0.20 divided by 0.10. So, or I could, I guess, find out the moles of HCl, and then because of 1 to 1 mole ratio, that, and I've got the moles of that. Okay, I think I'll do that. So I just find out the moles of HCl, which is concentration times volume, 30 divided by 1000 times by 0.100. Therefore, 1 to 1 mole ratio is what I'm assuming. Yeah. And then therefore to find out the volume of barium hydroxide, moles concentration volume, moles is concentration times by volume, volume is moles divided by concentration. So it's just going to be my answer, 30 divided by 1000 times by 0.10. My answer divided by the concentration 0.20, I get 0.015. 0.015. But yeah, now I see it. It is going to be a 2 to 1 ratio because I've got 2 hydroxide and 2 OH minus ions there, so I've got 2 H pluses there. I've only got 1 here, so that must have a 2, and that's obviously just a 1. So it's because it's a 2 to 1 mole ratio, I'm going to have to divide this by 2. So my answer divided by 2, no, so it's going to be 30 divided by 1000 times by 0.100 divided by 2, and then the moles divided by 0.200. 0. I get 7.5 times by 10 to the power minus 3 moles per dm minus cube. I want it in centimeters cubed, so it's going to be 7.50. Bit of a tricky one. Question 10. What I would do here is look at the difference between these two. So 1 divided by 0.050, that's a 20 times difference. If I do that, 1.001 divided by 0.050 times by 20. So what am I going to do to this? The volume of water, I'm going to times it by 20. Therefore, 100 centimeters cubed should be the total of water of H2O. However, that doesn't mean I need to add 100. I already have, I'm provided with 5 centimeters cubed at the beginning. So I only need to add actually 95 to get to the total of 100. And that last bit is probably the most trickiest. A solution of lead 2 chloride contains this much of that in that. So I find out the moles easily. Mass over mR. I want the concentration of chloride ions, but I can see here PbCl2 So the concentration of chloride ions in the solution is going to be whatever it is times by 2. So that's the key thing. But I've got the moles. This is the volume, moles of concentration. Volume concentration is going to be my moles divided by my volume times by 10 to the power minus 3. So 1.08 divided by 278.2 divided by 100 times by 10 to the power minus 3 times by 2. 7.76 times by 10 to the power. But okay, so I get moles is mass of mR, and then I do my moles divided by the volume, and then times it by 2. 7.76 times by 10 to the power minus 2. Yeah. Next one, question 12. What is the minimum mass in milligrams of zinc needed to react with this much of HCl? So I find out the moles of HCl, concentration times volume, and this is going to be very easy. Just remembering to convert centimeters cubed to moles per dm cubed minus cubed by divided by 1000. But now I can see it's a 1 to 2 molar ratio between zinc and HCl. So whatever I get from my moles of HCl, I need to divide it by 2, and that will give me the moles of zinc. However, I don't want the moles of zinc. I want the mass of zinc. Moles is mass of mR. Mass equals moles times by mR, which is 65.4 of zinc. But I want the mass in milligrams. This will give me the mass in grams. So to go from grams to milligrams, well, to go from milligrams to grams, I divide by 1000. Therefore, to go from grams to milligrams, I times by 1000. So actually quite a lot of steps, but it's not too difficult. And then do that times by 65.4, and then times by 1000. So I want it milligrams. 2.75 times by 10 to the power 1, 2, 3. Perfect. Question 26. Okay. This much of anhydrous sodium sulfate. Na2SO4, I'm pretty sure. It's that. Dissolving water in a solution made up to this much of the volume which flask was the concentration. So I don't think this is that difficult. I can see the pathway. I'm not sure if it's correct, but this is what I'm thinking. Find out the moles. 4.85. 4.85. Yeah, 4.85 divided by the MR, which is MR of Na is 23 sulfur 32.1. So 4.85 divided by 23 plus 32.1 plus 64. I'm not just going to write that down, I'm just going to write MR sodium sulfate. But I don't want the moles, I want the concentration. Moles of concentration, volume concentration is the moles divided by the volume, 250 in moles per dm minus cubed times by 10 to the power minus 3 to convert into that. So it should just be that simple. I should get 0.137. We'll see if I'm right. I don't think I am because I'm not sure why. And then to final, actually let's mark this. So question 5D, perfect. Find out moles, 2 to 1 molar ratio, that's the difficult part, because obviously we've got HCl, we've got 2 H's here, so we need to have, this needs to be 2, that's 2 to 1 molar ratio. Question 10b, perfect. Question 11d, perfect. Concentration of chloride ions, we need to times it by 2, PbCl2. Question 12c, perfect. We want it in milligrams, we've got it in grams, we want it in milligrams, need to times by 1000. And question 26b, I got it right, indeed. But what I can tell you about all these, they all have a quick trick in it, and a lot of these multiple choice questions do. Like in this case, it was you need to divide by 2 your moles, 2 to 1 molar ratio, etc., etc. And in this case, you could say you have to work out the formula of sodium sulfate, because if you didn't know the formula of sodium sulfate, you couldn't have got the MR. However, this is how you do it: sodium Na plus, sulfate ion, you should know, SO42 minus, Na2 SO4. Just swap numbers around, and because that's already a minus, that positive minus, and therefore there's nothing there, it's neutral. So that was that. Got all of them correct, that's pretty nice. However, there's one last question I want to go through that I did a previous YouTube video on, posted on. However, I didn't actually go through it. Reason being, well, I did go through it, but I didn't, talk. I just did it without talking. Question 3. Use information below to answer this question. And looking at this question, I was like, how would you do this? I just don't know how to do this. And then I saw a video of somebody going through it, and I was like, oh my days. Use information below to answer this question. A saturated solution of magnesium hydroxide contains this much of magnesium hydroxide, this much of solution. In this solution, magnesium hydroxide is fully dissociated into ions. Which one of the following is the pH of a solution of magnesium hydroxide containing this much of hydroxide ions at 298 Kelvin? Kw is that at 298 Kelvin. First thing I'm thinking, Kw. So we're definitely going to have to use Kw is equal to concentration of H plus times by concentration of OH minus. We want to find pH, so we need to rearrange it. Concentration of H plus equals Kw divided by concentration of OH minus. But then I think they've given me all of this information as well. So then maybe I have to work out the moles, mass over MR of magnesium hydroxide. Then rearrange it, moles, concentration, volume, to find out the concentration of magnesium hydroxide. And then maybe subtract it from here. But in reality, all of this information is useless. It literally is. If they removed all this information, you could still answer this question and get it correct. I don't know why. Obviously, I have a feeling they just did it to put students off. All you need to know, they've given you hydroxide ions, you can easily find out the pH. All you have to do is Kw 1.0 times by 10 to the power minus 14 divided by 4.0 times by 10 to the power minus 5, concentration of hydroxide ions. 1.0 times by 10 to the power minus 14 divided by 4.0 times by 10 to the power minus 5. pH is minus log 10 on my answer. 9.6. That's simple. That's simple. You don't times the hydroxide ions concentration by 2. It tells you a solution of magnesium hydroxide contains this much of hydroxide ions. Don't need times it by 2. And you get the answer 9.60, 9.6. Just be wary for these type of questions, but they give you a ridiculous amount of information. But in reality, it's a very simple question. And hopefully you guys found it useful.